Hello, today we're going to look at Rhino interface for Sofistik. There is many workflow. We're gonna make a geometry in Rhino. Maybe simple framing with a cantilever beam, and also one simple plate that we can manipulate the geometry. And we'll use text input in order to define the loads in Sofistik, which sounds a bit complicated, but we go through baby steps, how we can define the text input. And eventually we're going to also look at the results from Sofistik that we can export as IFC file and link it in Rhino so that we can compare original analytical lines and the final physical output from Sofistik.
As you can see in homepage, if you go to Sofistik homepage, you can download software. Trial version you can download, or if you're a university student or university teacher, then you could also download educational version. It also has wiki page from Sofistik homepage for Rhino interface, which updated in 2018 version. But the function is pretty much the same in 2020 with Sofistik. Let's go to Rhino's toolbox here. If you install Sofistik for Rhino, you can see here Sofistik tab from our ribbon, or if you type toolbar, then Rhino bring the toolbar, and we can see here Sofistik for Rhino toolbar. You can click each category and it will show toolbox for that each category. Basically, you have main Sofistik's main toolbar, and then we have the supports visualization and local coordination visualization tool. I have already drag and drop to the toolbox here in Rhino, so you can see we have Sofistik and local coordinates visualization and support. It's already prepared, so I'm just gonna close them. And also another important thing is Sofistik property window box. If it's not visible when you install, you can go to Sofistik and click on structural property. This window is very important. We can give members information and support condition and all kind of material information, and also cross-section information. And it also divided by 4 parts, which is point and line element, and area, which is surface element, and also coupler elements. I'm just gonna drag and drop next to the layer, so I can always flexibly manage my property. I'm going to change layer name here, layer 1 to support, and layer 2 I'm going to make it to member, and the others I don't really need, so I'm just going to type purge in Rhino, and I'm going to delete all unnecessary layer. Sorry, we don't have any extra elements for member, and it's not selected, so it's just purged. I'm just going to make it blue and make a new layer here. So I'm double click on the member, and let's draw one single line. If you go to Rhino here, you can click on line element, and I'm going to go double click the view, and from the front view I'm going to make it to position of start line to 0, and I'm going to type 3 meter and click. So I have one 3 meter line here in perspective view. By the way, in structural calculation, I think it's nice to use meter unit. So here you can see it's a meter, and on the unit setting, when you hit mouse right button from here, you can see it's a meter. And I would like to make display precision a little bit higher, so that we can get the exact coordination when you apply to the Sofistik's load cases. I'm going to hit OK. And now let's draw horizontal line for our beam. I'm going to snap our end point of the first column, and this time I'm going to type 2 meter, and I draw 2 meter cantilever beam here. you see we have 2-meter beam and 3-meter column. And I'm going to double click, select my support layer, and I'm going to click on point, and I'm going to define this point as a support below at here 0.0.0 to indicate our support condition. After you set your analytical lines and support condition, you can save you have to save your Rhino file. I'm going to override the file that I prepared from before, and that we can now actually use now this line and point as an analytical model. So I'm going to select line, and on the Sophistic here we can define it as a structural curve, and we could now define a different property of this curve. I'm also going to define here cantilever beam as a structural line, and the support condition I'm also going to define it as a structural point. Now what is important, we can export this Rhino file as SSD project. I'm going to hit OK, and Sophistic will ask you to choose specify specific code for your requirements. I'm going to choose Eurocode, and it's automatically 3D FEA system. I'm going to hit OK, and that's how we can define the SSD from Rhino. Now I'm going to double click on existing material. We could actually change this to, I would like to change the structural steel. We keep the material number to number 1 and change. And let's change this material. I'm going to make it to perhaps, let's make it aluminum plate. And let's make new material from code. And I'm going to select probably OSB board, this timber board, to show later different analysis on our area, surface area. Cross section we can also create. I'm going to make a new standard cross section from steel profile. From the code we can change the type to HEA, which is fine for me. I'll leave it to 180, the profile shape. Then all the properties automatically inherit from our cross section here. I'm going to hit OK, and I'm going to make another new standard profile. This time instead of HEA 100, I'm going to make it 100, maybe 280. So we have a second profile. Now if you go back to Rhino, when I select, as you can see here, we can define element type. I'm going to change to centric beam, and we can now define our cross section from central data bank, which is SDD file. We defined already from there material and profile. I'm going to select 280 HEA for the column, and second, I'm going to also make it to centric beam. Let's make 280, and end cross section I'll leave it as the same as before. You can also define hinge condition and support condition and more details, but for now I leave it as a default. And the support condition I'm going to fix XYZ position and also moment XYZ. So we completely fix the boundary condition for 6 axis. Now I'm going to export this Rhino model to Sophistic once more, and if you look at the visualization, now we can see the profile which we defined is properly exported from Rhino, and you can see the group name. The group number is 9, and the group number is here is also group number is 9, which is a bit strange because I defined group them to group number. Okay, that group number was by layer, so I'm going to change the group number here. I'll skip group number 1, and that also is defined as group number 1. And once more I'm going to export the mesh from Rhino, and if you click here from the visualization settings, if you click the member, somehow I cannot click, Alright. Why I cannot select? Let's see. Yeah, now I can select. When I select, if you look at the property, as you can see, the group number changed to 1, and that group number also changed to 1. The division of this mesh, the profile, is based on when, export setting. When we export from Rhino, we use default setting, so it automatically creating quad angle mesh geometry. But the detailed information to modify these settings, you can reference Sofistik Wiki page, and if you go to export and meshing, then you can find all detailed information how you can modify the meshing geometry. For now, we have now export this simple cantilever beam and column to Sofistik SSD system, which means actually we can also visualize our section. So when you hover your mouse cursor, if you click on mouse left button, it shows your member which already being exported from Rhino. And also we can bring this geometry from Sofistik to Rhino to visualize the situation. And if you look at our Sofistik here, there is a little bit of funny situation, because when you look at here the preview, the orientation of the beam and column looks like that, but in Sofistik the orientation is correct. So in this point, actually I'm not too sure what's happening. I should ask this to the Sofistik colleagues. Maybe I'll get back to you next tutorial what we can do with that. But what is nice about it, we can also extract mesh from this preview. So here, when you extract, we can now cell mesh. Okay, the extract option is not applying for the beam. It's only for later structural area we can extract the beam element. So yeah, unfortunately we cannot extract the beam geometry. But never mind, it's not important for now. We can also visualize our support condition. If you go support visualization, show support, and we can see right now it's very small, but on the settings we can make it a bit bigger. Then you can see that's the complete fixed condition of our support. And here I'm going to put one more point. Let's make it to road. I'm going to make it to perhaps pink color, and I'm going to put one more point here along the curve line. Let's remove the view of this profile, and I'm going to again click points, and let's define somewhere here. And in Rhino, when you type what, we can define point coordinate position. Here it shows x coordinates and y coordinate and z coordinates. That's the reason why I choose on the unit here, mouse right button, unit setting, the display precision, I increased it. Let's make it maximized to the highest precision, and you type what, then we have here. I'm just gonna copy and paste, and let's go back to our SSD file, and here we can mouse right button on project navigation. We can insert task, and I'm going to use text input for roads. So I'm just double click on that, and now let's type the syntax load case 1, and we can say point. By the way, there is a help menu. If you press F1 from there, then you can see all this sort of syntax information from the manual here. So we're going to define load case 1. Point means point load, and I'm going to define auto. And actually you don't have to type everything in capital. You can just leave it as a small letter. So auto, and I'm gonna you define type, the type of the load. So let's define it, the z and z projection z axis. So here I'm going to put about 2 minus 2 unit, and then we can define now the x and y and z coordinates which we copy and paste from Rhino point. And I'm going to copy and paste, but be careful here, we don't need comma, we just need space to put the coordinates of the point. Now I'm going to calculate, mouse right button, calculate text input point. It gives me error where the error message is saying it's 0 warnings, but it gave me error. I don't know why. Let's try again. Now it goes. So it was there. I put this hyphen. Actually, we don't even need hyphen. Let me calculate again. It should work. Yes. So now I'm going to go linear analysis. I'm gonna recalculate the whole geometry, and in the system, as you can see now, we can click on our point load, which apply to in the summary in this point, as you can see. And I'm going to perhaps let's make it higher, so we can always change this input to I'm gonna make it to 20 units, and I'm going to recalculate it. And let's do the linear calculation once more. So if you go here, now when I go 20, and you can see the deformation is bigger. And if you double click on the element, and you can see also the node point information, and here we can see the maximum displacement and utilization. So it's like so that it's not that big deform. I'm going to also change here the direction. Let's say instead of PZZ, this time I'm going to give load to X direction. So X direction means from here you can see that's the X axis. So let's click and calculate. And I'm going to do linear calculation once more. Then as you can see, when we go to now it's a PX direction, so the load is from X direction to minus 20. So you can see how it deforms the geometry. Let's try one more time. Then this time I'm going to define to Y, PYY, and instead of 20 minus, I'm just gonna give 20. So which means we go to Y direction towards 20 unit. Let's calculate, and I'm going to calculate linear analysis. And as you can see, when I go here, that's the reason why it giving me the error, because there's a structural failure. When you see this, when you see the animation here, if unit 1 means actual structural deform animation, and when I click on here, as you can see, Z direction is more than the Z direction. The Y direction, yeah, it has 15 millimeters of utilization. And when I click here, it also shows big structural failure. So that's why it gave the warning. Now if I change this to, for example, PZZ, and let's calculate once more, and I'm going to calculate the linear analysis. And when you look at the view, and here it should go towards upward, because the force come from down to upwards. So that's how we can use the line element for Rhino interface, and we can always bring the not result, but the view from Sofistik. And I don't know why it has now, probably because of the structural change, it bring different position of the preview. I'm going to move on to say let's draw one plate. So I'm just gonna define here plate, and I'm going to use plane commands to draw some sort of complete plate, and let's define that as a structural surface, and we can use this to define different materials. So I'm going to use, this time I'm going to give group number name 2, and thickness we can leave it to 20 centimeter, maybe 10 centimeter I'll make it. And material, let's define to aluminum, which we found it there before. And I'm going to define one more extra support. This time I'm going to use line command and draw one here, line, and this curve I'm going to define as a structural curve as well. But this time I'm not gonna define any element type, but I'm going to define support condition. So I'm gonna fully fix here. Now let's go to Sophistic to give the load case. Before that, I'm going to export this geometry now to Sophistic central data bank. So when you see preview, now we have both linear this steel framing and also the aluminum plate on this visualization tool. So I'm going to put the extra here, the new load case. Of course, we can give load case 2, LC2, and this time we're gonna define this as area. So we can type here area, and we can leave it auto option, and on the type I'm also gonna give to that, and let's make it okay 10 units. And now we have to define four different points so that we can define the boundary condition of the load, area load. So what would be easy, I'm just gonna disable this. What would be easy for now, I'm going to put the points on type points in Rhino, and I'm going to type points to each end of the, or maybe we can type what, and here it should be able to see the coordinates, but it doesn't show. And let's make each point where the coordinate is. So I'm going to copy and paste directly to here. This time I'm going to define x coordinates 0.1, and we don't need these things. So, and then next let's take second one. So we define from first point, and I'm going to say what second point, and gonna copy and paste. I know this is a bit time consuming, but we have better option. I'm just gonna show just from the scratch what we can do with this load text input. So please understand it's not the best option, but it's good to know how load can be applied in text input. So here I'm going to type here, and we don't need comma, remove it. And the last point I'll define to x4. Let's make it here so what, and we can type copy and paste once more. Yeah, then we define basically the 4 coordinates of our area location. And now if I hit calculate, it should be able to calculate the load, and we go to calculate linear analysis. then it succeeds. And when I go first, this is our first load case which applied to the beam. And if I click second, here you see the load applied to the plus, I believe. That's why the aluminum plate are going upward. Let's go to here, and I'm going to define to minus this time. Let's exaggerate it to 100. And now I'm going to calculate once more. And let's calculate linear analysis. Then, as you can see, now we have like total 1498 kilonewton which applied to there and which goes downwards. So you can see whole deformation of plate. And what would be interesting if I now go to the Sophistic, and if I go this plate and property, and instead of the aluminum, I'm going to define it the different material, double click, and OSB board. Let's see here, for example, the deformation. If you look at when you click background here, then you see it shows tension and compression. And when I click on the first element, then it shows the deformation, which is about that much. And now if we export timber property, because the material changed, it must have different property. So I'm going to again calculate the load. Actually, you can calculate all of them from here. And when you look at them, then looks like there's some structural failure. Let's have a look. So as you can see, when it's timber material, you see the huge deformation is applied and structurally fail because of the material property. So this is very nice. And we're gonna look at also line. We looked at for the here line point load, but what about line load? I'm going to move this point to the end of the beam, and let's copy one more point, the start of the beam. And if we go to Sophistic here, instead of point load, what we can use is now we can use line load. So line, we can also make it instead of point, we can type line, and we make it automatic. The start point of line load, let's see, I think it's x. We can also define x1. It must be 0, xy 0, and has to be 3 meter. And then second one should go to x. Let's find out the position. What I'll type, and 2 meter by 3 meter by 0 by 3. So this is good. We can copy and paste. Instead of column comma, we have to remove the comma. And now if I calculate load, then it will calculate line load. And let's calculate linear analysis. So when you look at the here, it applies a line load along the curve. So that's how it works. It applied to 40 kilonewton because of the we have here 20. Let's leave it to -2, and I'm going to calculate once more all of them. Then sorry, it didn't. Sorry, I forgot to calculate the text input. Calculate load. And now I'm going to calculate linear analysis. Then, as you can see, here we have -4 kilonewton, which goes downwards. And of course, this we can exaggerate from the amplitude here, but deform in 1:1 scale without any big displacement. You can see from here. And what is interesting now, what if we change the geometry here for the plate? I'm going to rebuild, and I'm going to divide it to 4x4 UV direction. So if you look at F10, that's our new UV grid for this surface. And I'm going to manipulate geometry a bit more complicated. So, you know, we have complex geometry here. Now I'm going to export that to Sophistik's central databank, and we calculate once more the geometry, the load, and now I'm going to change linear analysis. And if I look at now, as you can see, the whole plate geometry also changed automatically here, which is nice. And I'm going to click, and you can see the deformation because we defined the load which is within that range of the point. But what if I change then the position of the another point here? Let's move it a bit further. Then let's export once more, and I'm going to update the loads and also linear analysis. Then it doesn't work because it doesn't know, if you look at the calculation, the failure, it says, wow, wait, load case 1, it worked, warning 2, warnings occurred, no load defined for load case 2. It's because the point is out of the range. So in this case, of course, we can find out another point location from Rhino, for instance here, and when I type what, then it will show the coordinates here, and of course we can go back to SSD, and the last point we can update it to the new point boundary point position, and I can recalculate it. Then we can do the linear calculation. Then your calculation would work, as you can see. It's just because of material, it's a structural failure. But if I change to this material to this time, instead of OSB board, let's go back to aluminum, and I'm going to export again. And we do same process, going to recalculate the load and linear analysis. Then if you look at now the plate, I'm going to show the cross section, and as you can see, it shows very nice animation from the calculation. And this result we can also display in here, as you can see, and we can extract the geometry. And when I now cell mesh, we can move it to there. Also, we can move it to there, and we use this. I'm gonna change the layer. Let's change the display color. It doesn't really meet the property. We can change this layer to black, and we can change by layer. So we can see the different this mesh geometry from Sofistik, which I found is very nice because you can use maybe a little bit more advanced design or form finding strategy with this. Now but what if we have to keep change the geometry from Rhino? I don't know, maybe the design evolved and it became a little bit more complex. I don't know, something like that. And every time when it changes, it's difficult to define the position of point. Basically, we need bounding box of this surface, and then we can give the bounding box position of coordinates, but this is still time consuming. So in this case, I'm gonna export it. There is also automatic way we can define the area load without these coordinates options, which we can use. Same, we're gonna apply load case to area, and we can reference. If you look at the help menu here, we can reference group of quad element. So I'm gonna reference QG RP, group of code elements, and we can define the group number. So I can NO to define group number, and this guy group number was I defining as a 2. So when I go SSD, I can give number 2, and then we can project load to Z direction, and we're gonna give the type as a default type, which is PG, which is load type and direction. PG, I think PG means it's gravity direction. So I'm just gonna leave it to PG, and we're going to define the value. To define value, we have to type P, and I'm going to define it to maybe P1 to has a first value. I'm going to make it to let's say 10 minus 10, and if I calculate now, succeed. And when you go to linear analysis, and let's have a look now. If you look at this, doesn't change much. That's strange. Let me export once more. Text input, we're gonna calculate linear analysis. So in the visualization, my computer is a little bit fuzzy. Don't know why. Yeah, now if I look at it's somehow it's too slow. Sorry, maybe I'm just gonna close it first. I'm gonna save the project, yes, and let's open again the central data bank file. Yeah, and then I click. As you can see, the SSD is applied. Sorry, the load is applied, and I'm going to double click. Yeah, so this is the way we can define the referencing the code group number 2, and we can project to the gravity direction, and we can define, this time I'm gonna maybe exaggerate to 200 units, and I'm going to calculate once more. And when I go to linear calculation, when you see the visualization, then they deforms much more, as you can see. And what is nice, when you have Rhino plugin called Visual Arc or Geometry Gym, if you have them, you can actually import IFC file from any other software. So Sofistik does support the IFC file. When I go here, file, we can IFC export. Sofistik support IFC2x3 coordination view 2.0. I'm just gonna select that, and there's option we can which group we want to export, and original shape, or we can also export the deformed geometry. Let me export first original shape. Sorry, I have to define where the target. Yeah, so I exported it already. So in Rhino, if I now import so import to, sorry, Sophistic Research, not that. Point on studio, sorry, I'm just gonna remove. Import to from here. One of those plugin will give you to see the IFC file of the result from Sophistic, which is very nice because when you see here the IFC tag, it comes as a beam, and that comes as IFC slab. So which means you could also see the result, this meshing result, or the profile members as IFC that you can link in different beam software. And I'm gonna try one more time to export. This time let's define option, and we're gonna use deformed geometry, right? And I'm gonna define the type to deformed and export. If I now import that result, deformed result, you can see the deformed geometry from Sofistik. This one it doesn't show because we applied only one direction, but if I do IFC export, this time if I go option to show this deformed to the beam, and when I'm gonna override it, yes, I'm going to import once more. But if we insert, sorry, I'm gonna drag and drop to Rhino, deformed, and Rhino will give me option. This time instead of import, I'm gonna attach as a link. So let's see if it works. It takes a little bit more time to attach IFC file. Rhino just crashed, unfortunately. So maybe attach is not a good option to try. I'm gonna open Rhino again. So it was crashed. So I opened Rhino again. Let's import again the location and the deformed. On this time, we must be able to see the deformed structural beam position. Because the deform is not really obvious for that load, so it doesn't show much. But let's change the load case. Load unit. I'm going to give just to exaggerate. I'm going to give 2000. Let's calculate. Definitely gonna be fair. In linear analysis, it will show failure. I guess. It's okay. So let's see. In this case, we have huge deformation. So if I now export this file, export IFC, the same file format I'm gonna define to deformed, and I'm going to use this option to export it. Yes, and I override it. And when you go to here, I'm gonna import one more time IFC deformed one. And when you compare now, you can see that shows the maximum deformation of the maximum displacement and the deformation of the structural elements. So I think it was a little bit too much information maybe, but we're gonna discover more in terms of Rhino tools, some more functions in the next tutorial. And instead of using text input, because text input I'm also not very familiar and it's a little bit tricky, you need more practice to use it. But it's very powerful because you can apply the load case pretty much automatically by assigning this text input. But we will look next tutorial. We're gonna look at some options using Sophie Plus to assign the load case from Rhino geometry. So we will make a geometry from Rhino because Rhino is much faster to use in 3D space than AutoCAD background. And then we'll bring this system to Sophie Plus, and there we will define different loads with the Sophie Plus tool. In this case, we can graphically assign the loads instead of text input. Perhaps maybe it could be more interesting as well. So thank you very much for watching it. Today, yeah, I don't know, maybe it was a lot of information, but I hope you kind of get basic idea how we can use Rhino interface for Sophistic. And if you have any question, please feel free to ask me down in comments, and I will leave all the detailed information of the links on the description box. Thank you very much, and hope you have a nice weekend. Bye bye.